All right, welcome, ladies and gentlemen, and thank you all so much for joining us today. On behalf of AUVSI, we're very pleased to welcome you to today's webinar, a rapidly deployable UAS VTOL maritime ISR capability with increased operator situational awareness and sensor analysis capability. So my name is Shannon Walker. I'm the program manager here at AUVSI and will be your host for today's webinar. And before we get started, we always like to cover a few of those housekeeping items. So first off, all of your participant lines will be muted during today's broadcast. A recording of the program is in progress and it will be emailed out to all of our attendees along with a copy of the slide deck and posted on auvsi.org within the next week. If you're listening today and you need any assistance, please send a note to the webinar leader using the chat box on the right side of your screen. If you don't see that chat box, please click that little chat bubble icon that is located at the bottom right-hand side of the screen, and that should open up the chat box panel. Please note that any links that are featured in the slides will also be shared through the chat during the presentation. After the presentation is over today, we're going to open up the session for Q&A. So attendees, you are encouraged to submit your questions at any time throughout the webinar using the Q&A box on the right side of your screen, but those questions will be saved to be answered at the end of the presentation. A quick note, this is a different box than the chat, so please submit all of those content questions for our speakers using the Q&A panel, which can be found directly underneath the chat panel. And then another quick note for attendees, you can change your screen view by clicking the layout icon found in the upper right-hand corner of the slide screen. So for example, if you want to see our active speaker, you can deselect the option that says show participants without video. The stack view will show the speakers above the slides. The side-by-side view will show the current active speaker larger and next to the slides. So feel free to play around and find what works for you. All right, enough of that. Let's get started. We are very excited to welcome back and thank our sponsors, Kongsberg Geospatial, for their support today. We are excited to kick off the year with two excellent speakers, Rex Hayes, the Director of Unmanned Systems at Kongsberg Geospatial, and Mark Russell, the Director of International Business Development at Shield AI. So today's webinar is brought to you by Kongsberg Geospatial, which is a subsidiary of the Norwegian company, Kongsberg Defence and Aerospace. Kongsberg Geospatial is headquartered in Ottawa, Canada, and creates mapping and geospatial technology for a range of mission-critical applications, including defense systems, air traffic control, and airspace awareness software for unmanned systems. Kongsberg Geospatial are the creators of the TerraLens real-time geospatial SDK, and Iris UXS, a ground control station and airspace visualization system for safely operating UAVs beyond visual line of sight. Kongsberg Geospatial has been working to develop a standards-based system for recording, accessing, and comparing real-time and historical sensor data captured from unmanned systems. So, from Kongsberg and with us today is Rex Hayes, and Rex has been in the unmanned industry since his program management days while on active duty with the U.S. Coast Guard. As a helicopter pilot, he understood the huge potential of unmanned aircraft, and after retirement went into the unmanned industry, starting as a subject matter expert at Booz Allen Hamilton, and then with Textron AAI as managing BD director for the Aerosonde and Orbiter UAVs. After Textron, Rex started his own company, assisting multiple companies with their unmanned goals and strategy. Rex then joined Kongsberg Geospatial last year as the U.S. unmanned rep, appreciative of the fact that data and presenting that data was at the heart of most unmanned operations. And joining Rex today is Mark Russell, who served with the U.S. Air Force as an aviator and C4 ISR officer with over 4,000 flying hours, 500 of those combat hours, commanding special mission platforms. After serving in the Middle East in 2007, he retired from the Air Force and served as president of Impact Armor Technologies, a high-tech startup producing and testing a lightweight composite armor. After the acquisition of Impact, Mark went on to work for Raytheon Missile Systems and later for Institute, a Boeing subsidiary, where he was responsible for sales of Scan Eagle Integrator and RQ-21 Blackjack systems. He later joined Martin UAV, now Shield AI, where he is the Director of International Business Development. So Rex and Mark, we are thrilled to have you with us today, and I will turn it over to you, Rex.
Okay. For those in the Eastern time zone, good afternoon. If you're in a different time zone, either good morning or good evening. Shannon, when you have two people like Mark and I that have been around for a while, the introductions take longer and longer. Just means we've had a lot of time to do different things. This is clearly a joint op between the Air Force, the Coast Guard, and the Navy with Mark and I. We've worked together previously too. So we have actually a good group here. My other panelists from Ottawa, Dominic Mancini and Chris Gagnon. They took time out from the truck protest to join us today. So thanks guys for making this. As we kick this off, Shannon introduced the topic, rapidly deployable UAS VTOL maritime ISR capability, blah, blah, blah. We could have probably went with a shorter opening and said, with the VTOL UAS and two pieces of software, you can turn any maritime vessel or any asset really into an intelligence node. That's what today is. And I think you'll appreciate that after the brief is done. So what I was going to do today is I'm going to start with talking about the different pieces that made up that sea trial. Mark's going to talk about the VBAT, VTOL UAV. I'm going to talk about Midas and Iris that Shannon already described a little bit. We'll get into those capabilities. I'll tie them all in together to the sea trials. At that point, we'll go through some video to show you the sea trials in real life, which occurred in December. Then we'll open it up to some Q&A. Okay, so I have to give a shout out to Kongsberg Geospatial History. This is a great eye chart, by the way. We turned 30 years old today, or this year. We started as Gallium Visual Systems in '92. In '06, Kongsberg, our parent company in Norway, acquired us. And in 2012, it was renamed Kongsberg Geospatial. So on this chart, just note some things. Again, it's U.S. and international programs that we're part of. Some very high-profile projects. We're part of the Wedge Tail, the Maritime Multi-Domain Control System, Combats 21. So Kongsberg Geospatial is part of a lot of different international and national DoD and Homeland Security type programs. So I'm going to pick out 6 to talk about that are pretty relevant. Talking about recent and relevant, today is National Pizza Day. So everybody, we know what we're having for dinner. Also relevant and recent is that this week, Huntington Ingalls finished the USS Montana sea trials. USS Montana is a fast attack submarine, part of the Virginia class, which is that middle slide or that middle picture. Kongsberg Geospatial is part of that fast attack submarine program. Our product is TerraLens Inside. If everybody remembers the Intel Inside from the 1990s at marketing, we like to say TerraLens Inside. Again, we're on Navy Aegis Weapon Systems, fast attack submarines, the Navy Air Traffic Management Systems, ATCs, training systems, also the National Advanced Surface-to-Air Missile System, which has been deployed to about a dozen countries so far. The Triton MQ-4, and I'll say one of the best, but not for last, is the Coast Guard's National Security Cutter. So TerraLens is on all those pretty prominent programs. The other thing TerraLens is in Iris, the unmanned systems we have. So our pedigree is based on the TerraLens, which is in all these DoD programs. So as Shannon mentioned, Iris is a situational awareness, also a deconfliction airspace system. So this slide, I was actually kind of contemplating on changing it. It's broken into 2 halves, a fleet management half and an airspace management half with 4 quadrants. I think it should just be one circle because the fleet management side, which can consist of ground control stations, it provides a situational awareness display, and the airspace management side, which is a counter UAV component, and also a component in the UTM, Unmanned Aircraft Traffic Management System of the FAA. But Iris is all those combined together. One of our engineers gave a brief at lunch and called Iris a holistic solution, which it is. So while this has it broken up, Iris actually gives you one common operational picture for all those kind of things that you require in the airspace. On the fleet management side, we're kind of making our headway into drone delivery. We had 3 drone delivery partners. Flirty is now Skydrop, so they've changed their name. I've got to update that side as well. Just last month, a couple of weeks ago, we've gotten a fourth customer on board for drone delivery. So that is up and coming, and it's continuing on as well for IRIS. Okay, so how does IRIS provide this common operational picture? It takes disparate sensors and data, and it fuses and correlates them together. So starting on the ground up, the terrain map is TerraLens. So again, that's our TerraLens base. We import periodic aeronautical data. We can take any kind of data. It could be ADS-B, weather, traffic feeds. It can be AIS. All that can be ingested into IRIS. We take our own aircraft position through the sensor. We get the telemetry on that and the flight path. And then any kind of collision avoidance that can come out as a service for obstacle avoidance, terrain avoidance, other airspace avoidance by setting up alerts and cues. And also, if you have a DAA, detect and avoid system such as radar, we've ingested those as well. Okay, so how does it do it? It does it through a DDS or a data distribution service, which uses a middleware architecture. Okay, so I talked about those sensor and data feeds on top, the aeronautical data, ADS-B, the radar data, own ship telemetry, far right, takes in that as well. The most important takeaway from this slide is that other input. IRIS for every customer has been specialized for them. There's no one IRIS that's out there. We have a baseline IRIS, but every customer wants something particular added into it. So everyone has their other inputs into that. From all that data, we get the services. We get a detect and avoid, terrain avoidance and alert system, airspace alerts, vehicle alerts. We do have access to the cloud as well. So you can look at IRIS besides its own display as a web viewer as well. So why IRIS? Typically, this is probably an ATC. I'm flying out from PHL, Philadelphia Airport, in a couple of weeks, and this is probably the typical ATC. You have all your information on different screens. We want to get rid of that and put it all on one screen to bring the cognitive load down on the operator. So this is an IRIS screenshot. Okay, you have your map engine we talked about. On the right hand is your 3D map engine. On the center is your 2D map engine. On that engine, you can see there's different layers out there. It's all customizable. You could put ATC layers on there. You could put cloud cover layers on there. You could put obstacle layers on there as well. So any kind of layers you need to help your airspace. If you look at those two, and I know it's a little bit of another chart, but if you look at those two maps, you'll actually see multiple aircraft up there. So we can take ADS-B in there. We can take, again, if it's uncooperative aircraft, we can take radar hits in there. We correlate and fuse that all together, and we could put all the UAVs on there for a fleet management perspective. We can actually ingest some autopilots, and if we want to control our fleet, we could actually take control of that aircraft, and the camera will pop up and we'd be able to either direct it to a new waypoint or help it in landing. On the left-hand side, we call those cards. We get FMV of the aircraft we've selected. You can get track lists in there. Again, this is all customizable to things you may want. The other capability that we brought aboard sea this time was called Midas. Midas is simply a data storage and retrieval system that has a great analytical component of that as well. So while IRIS had the pedigree or the backbone of TerraLens, Midas has their back end from the Global Hawk or the NATO RQ-4. It managed to disseminate and display joint ISR data. So that back end that it was actually in the RQ-4 is part of Midas as well. So this is a typical application without Midas. You have an aircraft. Sorry, Mark, it wasn't a VBAT. So we picked a generic. Again, both our solutions, while we work with Mark and the VBAT quite often, a lot of deployments together, we are agnostic to the aircraft and to the sensor type as well. You have your typical standard GCS, which is your vehicle control and your payload control, but there's no real way to store and then analyze that data either later or in real time. So simply we added Midas. Midas connects through an Ethernet to the GCS panel. We get the near real-time FMV in that, which we'll show you over here. We also get the map down there, and we can actually track the aircraft. And while it's going, if somebody said, hey, was that air or was that ship or whatever there an hour ago, we can do a temporal search on that and say, go back while we're still streaming FMV and say, yeah, that ship is there, or here's the position it was in earlier. So Midas brings you that intelligence node, if you will, while you're still conducting operations. Okay, like how does Iris do it? How does the Midas do it? Again, it's the DSAR. So you have your payload operator, they have the payload. And if you have any kind of intelligence platform, in this case, Sentient, Kestrel, the motion detection software, if anybody's aware of that or has used that, we actually get that too. A little bit of a gap, but we'll get that. We'll make it into a mission file. We'll have the raw video feed. We'll have the control payload, lat long, all the types of metadata you need from that. And we can actually also, any kind of analyst tool like the Sentient Kestrel, we can have that as well. So you can go back and analyze that later. Okay, as I showed you the Midas screenshot or the Iris screenshot, this is the Midas screenshot. Again, it's the viewer. You have the FMV coming in. Instead of cards on the left-hand side, we have either products or mission files. So while we're doing a mission, you can start a mission file and categorize it mission, 1 Alpha 1 for this day. And anything that happens during that mission, you can save. If you're interested in a certain type of, since we're talking maritime, a boat, you can actually have any kind of information on that boat. We were on the John Harville, so you can have all the data on the John Harville as a product card. So where your analyst is doing this, you can actually pick up in real time any of the data that's associated with your target of interest. Okay, I'm going to turn it over to Mark right now, who's going to talk about the VBAT 128 and its capabilities. After that, we'll get back into the sea trial. So Mark, do you want to take control? Actually, I'll keep control. You just tell me to go to the next slide.
You keep control. Go to the next slide.
Okay, you got it.
Hey, thanks, everybody. Wow, Rex, every time I listen to that, I learn something new. And probably a key point here, a couple key points. One is the increase in capability that the Midas and the IRIS capabilities bring actually reduces a lot of the operator workload. Now, you touched on that. I think you called it cognitive workload or something like that. At the end of the day, a VBAT or a Sheeble or any of the other systems are means of collecting information. The key is, what do you do with that information? What I'd like to just quickly hit across the wave tops here would be about the VBAT 128, why this next gen capability is enabling us and our allies and our friends to do simply what wasn't possible 2 years ago. Next slide, please. Just a couple things here. Should not be any surprise to anybody here. You can see here, no launcher, no recovery unit, nothing, very small footprint. The whole concept is to have equal to or better ISR capability and other payload capabilities in that fuselage area just in front of the wing, but be able to operate it anywhere. We can take off from any firm surface, and as we just proved recently, even not so firm surfaces. But the thing can literally take off from any space. It's about 4 by 4 meters and go right up through a column of trees or urban terrain and land on top of buildings. It's actually pretty amazing. What I do also like is that we can set up and fly in let's say a trained crew in about 15 minutes, a fairly new crew in about 30 minutes. Once you're done, you can land next to your pickup truck, pack up, and you're out of there in about 15 to 30 minutes. Pretty neat. Anyway, very flexible operations, ship to land, land to ship, ship to ship. And then what we like about working with the Midas partners, and you're going to do the video later, right, Rex? You're going to show that?
I am.
Yeah. Is the amount of information that we can get to work in, let's say, national airspace, whether that's in the US or in Europe, is enabled by using Midas. You touched on the biggies, the MODES, ADS-B, got to have that sense and avoid, that spatial awareness around the aircraft when it's operating in very sensitive national airspaces is super, super important. Well, guess what? We can do that now. Next, please. Next slide. Just a little touch on the customers here. These are all public release customers. We have other customers that I didn't fill in here, and it's proprietary, so I didn't put it on here. But these are our big programs. You can see very heavy U.S. Navy, U.S. Marine Corps. U.S. Marine Corps is actually our oldest program. We're working with SOCOM, the U.S. Army. Competition is ongoing. Another relatively unknown operation is down in the Caribbean on that Joint Interagency Task Force South. We've been out there for over 3 years, working with our partners in the region. And again, circling back on the what couldn't we do 2 years ago that we can do now, we're operating off of boats, not ships. We're operating off of ships too, but we're operating off of boats that are about 20 feet long. And those things are bouncing around in very rough seas, and we're taking off and landing without any problem. You can imagine the flexibility that gives to an ally or to a friendly country. Next, please. A little bit about the air vehicle. Obviously horizontal here. It takes off and lands vertically. I've got a slide later. This is just some basic facts about the bird. These numbers are all public release. There's some other numbers here that are not public release that I did not put on the slide. Next, please. Flight profile. Takes off from its tail, transitions to wing, flies most efficiently on the wing, transitions to vertical and back to land. A little fun fact, and I'm not sure it's in the slides, we use a QR code, just like you take your cell phone and scan the menu in a restaurant. We've got a little camera in the duct that picks up the QR code on the ground and lands on the card. So if you have that in the back of a pickup truck and the pickup truck is moving, the bird will come in, transition, and land on that card in the back of a pickup truck. Kind of neat to see. Hard to believe, to be honest with you. Next page. Couple pictures here. One I'd like to call out. So our Army colleagues here on the left, there's a QR code in the middle. You can see the romantic looking picture in the sunset. Over on your right, while it might not jump out at you, the top right in particular, this is one of our military deployments, and we take off and land routinely in between helicopters on the decks of ships. Now that's a fairly unusual thing to do for UAVs. Most of the time they want to move the helicopters out of the way or any other high value assets. Well, we're taking off and landing right smack in the middle of where the helicopters and other fixed wing aircraft are parked. Pretty big deal. Let's get back to that theme, what was not possible 2 years ago and why. Next slide. Some of the logistics. That is our footprint there in the Black Hawk. That's a fully deployable 2-week system. You can see the knee there on the just inside in the front and the back of the door there of a person sitting inside. That's a fully deployable system inside a helicopter. Over on the left, because we have such a small footprint, logistics is super simple. Got an illustrated parts catalog. You just click on the picture of the thing you want, and it drives it to the part number. We also work through our foreign military sales partners through the U.S. Navy. And the whole idea here is we just keep getting a smaller and smaller and smaller footprint with greater and greater and greater capability. Next slide, please. Back to you. Thank you.
Okay. Mark, thanks so much for that. So I'm going to talk now about the actual sea trials. That's what you probably all came to hear anyway. So we performed the trials on contract with Defense Research and Development, DRDC Canada, with an assist from the Canadian Coast Guard as well. They also joined us on the sea trials there to go over some of the requirements they were looking at. So right-hand side, the offshore sea trials took place in international waters, and that is the Gulf of Mexico. So we're about 100+ miles from Galveston. That's where we took out a port, and we ended up 12 hours later in the middle of the Gulf of Mexico. Interesting weather down there, as some of my colleagues can allude to. We had about 20-25 knot winds, about 6 to 8 foot swells. It was a pretty good trial to see how this capability went. We were on board a supply ship, which is the one on left, the Joan Harbaugh. Some people called it the SS Minnow, but it was the Joan Harbaugh. She actually rode pretty well. And that was it. So we took a ship with limited, and I mean very limited radar capability, and you're going to see what we gave it. Okay, so this slide represents VTOL UAV, iris top right, Midas bottom right. Those 3 pieces right there took that ship and made it into an intelligence gathering platform. Complete airspace, surface situational awareness. You had an analytical ability as well, and I'll break into any one of those pieces there, okay? So all sea trials start with an onload and install. The video will actually show this a little bit better, but there's no cranes needed. There's no heavy lift equipment needed, as in some cases, it literally is a bunch of folks hauling boxes out of a transport van onto the back of the ship. I would say it took us 20-25 minutes, if I remember correctly. And as Mark alluded to, that top left, that is your deployed system right there. Those each of those gray boxes carries a UAV, one UAV VBAT. And the boxes in front are all your ground support equipment, maintenance equipment, payloads, ground control station, whatever you need. So that's your footprint on board the ship. As Mark said, you can go on a crowded flight deck for a military ship and you'd have no problem with it. The install is another feature. Sometimes you have to cut and weld and do some kind of ship alterations or ship alts. We didn't have to do that. We found the access port in the wheelhouse. We ran a couple additional wires out, 4 to be exact. Martin UAV put their direct radars on the port and starboard side, and that's Dom up there. And we put up a antenna for AIS, and Clay, who's a Shield AI guy, great guy, put up a UAV Onyx ping station for ADSB. They were all just tied on, no cutting, no permanent fixtures or anything else. It took us 2 seconds to actually offload that as well. So that's all it took for the onload and the install. Continuing on the install, this is what it looked like in the wheelhouse. If you remember that picture, it's not a large wheelhouse at all. We set up a small table on the top left picture. That is the GCS. That's the controller and their display as well for the payload. And the one operator there, our team was next to him. In the middle was Dom, who had the Midas set up, again, attached an Ethernet cable. Opened it up, we're ready to go. Chris was setting up Iris. Okay, again, it was taking all the AIS and ADSB feeds on the right. We took a little bit of the space on the chart table, but that was about it. Captain had no problems with us being in there. Never got in the way of anyone in the wheelhouse. Okay, the staging area. So you saw where the footprint of the logistics was. Again, we just opened up the box. That's where they put the VBAT together. That's what they put the payload on. They refueled it. Any kind of turnaround on maintenance. This is the footprint of the operation to actually get ready to launch it. So again, minimal impact on the ship structure, on the placement, and on any of the ship's crews at all. 2 people put it all together. The rest of us just kind of watched. I took pictures of it. Okay, so over 3 days, we flew multiple sorties. Matt, I told you about the weather conditions, so it was challenging but fun. Day-night operations. We kicked the tires for DRDC. We went up to altitude. We went beyond visual line of sight. Did any kind of capability things that they desired us to do. Quick turnaround on payload swaps, all that kind of stuff. The other thing we did was for the Canadian Coast Guard, we ran some scenarios for them. So on one, we did a sea dive marker. So bottom left, you can see, I think it was Clay and Dom dropping in the sea dive. It actually came in orange and turned green in the water. We launched the CBAT or the VBAT on that. And again, the whole idea was to say, okay, let's go find it. Let's go keep it and analyze it. So what we did is Midas, as you can see, there's the FMV of we took a picture of it, obviously, of the dye in the water. So we have the VBAT, we have the lat long of the VBAT, we actually have the camera, and that blue box is the field of view. So we actually have the date, time stamp, all the metadata for that sea dye. That sea dye could be an environmental oil slick, it could be collision at sea. That could represent a lot of things. The whole takeaway was that, okay, we found it, we have it, and now we've analoged it. Okay, so it's ours. We can analyze it later. Any kind of forensic stuff, if you needed, we can come back and use it for that as well. We did the exact same thing with a search and rescue or man overboard, if you will. We threw a life preserver in. That's the orange circle that's in the middle of that. The life preserver can also be contraband. Mark talked about working in GIF South. Guess what they do? They do a lot of contraband. They go fast. They throw stuff over when they're going to be spotted. Again, so it has applications in that as well. On the right-hand side, you'll see Midas. You'll see that the dots are the actual aircraft display, so we can keep that for reference. You'll see that blue line with the field of view going to in this case, the life preserver. Again, any kind of forensics, evidence chain of custody or command, if you needed that for further courts or anything else, all that could be saved and analyzed later. Iris, again, you saw Chris setting that up. We put up the UAV Onyx ping station instantly. This is not a made-up shot. This is on the boat. Instantly, dozens and dozens of aircraft, obviously all in the Houston, Galveston area, flying over there. We picked up one ship for AIS before our ship ever saw it. We went out and sent the DBAT. It was at night to go and confirm what we did. So we picked up an AIS hit. We had multiple ADS-B aircraft hits. The other thing, that deconfliction was real. We're watching it, and sure enough, we saw a helicopter. Don't ask me how they were doing it. They were 100 miles out in international water. They were flying in our area. Alerted the GCS operator and said, "Hey, we got traffic deconfliction." They quickly climbed, went to a couple thousand feet, and veered away from the aircraft. So we had real-time airspace deconfliction. So again, we weren't ready for that for the trial, but it worked perfectly for us. So again, the VBAT and the Midas and the Iris really turned that ship into things it would never have known before that it could have. All right, so as of all deployments, you have to have the obligatory photo with the aircraft. That was the crew there. Again, we had Canadian Coast Guard with us. We had the VBAT crew. It was a good deployment, 3 days, and we got a lot accomplished. All right, so now I'm going to go and start the video. Just give me a second here. And I apologize in advance if it's clunky on the video. Let me start that. And it's an 8-minute long video. I think AUVSI will send it to you if you want it. I'm just going to do the pertinent parts. So again, this is just to show you that back of the deck, the VBAT takes off, flies around. This is the offload I talked about. All the equipment came in that one Sprinter van. That was it. Again, you had no heavy cranes, no machinery, no forklifts. Basically, people just bringing it in. Mostly 2-person on one item. Some of us stopped working, myself included, talking to the captain. But that was it. It took no time at all. It was all out there. We go up to the next chunk here. Okay, and sorry for the clunkiness. Okay, so this one just shows you the unpack. Again, one aircraft in one of those gray containers. It's all modular. So Mark, sorry for speaking for you, but it's I've been a UAV guy for a while, but it's all modular. It's all put together. Everything's in there. Aircraft, obviously the engine, the wings, payloads, the whole 9 yards. Let's just play through a little bit just so you can get an idea. And then we did a little time lapse to show you the actual time it took to do that. And as Mark stated, that's the payload that goes up front for the FMV. We actually ran a drill where we swapped out the payloads. So we flew the Trillium payload, but I think the VBAT's agnostic into what type of payload it can fly. We had the HD, I believe, is the 45. Just go for a minute more. There's the changing out the sensor payload. We wanted to time that as well. And again, this wasn't rushed. It wasn't like promoted to say, hey, let's see how fast we can do this. This is just normal setup and time to do it. See, it's ready to go on the stern. So Mark mentioned they have that QCR code for landing. On this one, we actually had a differential GPS, which is that little gray oblong box on the ground, if you can see that near his foot. So it lands, as Mark, it could land in the back of a pickup truck, no doubt about it. It lands spot on. It's that simple. That's the takeoff right there. Okay, let me hit one more clip for you guys. As I'll just keep this running for a little bit. As Mark said, it comes out vertical and then it transitions to forward flight, so you get kind of the best of both. These are all the times for it as well. So 31 minutes. I think we even beat that. But well, you know what? I'm going to let it play out because it can't control it. So So you can get a sense. I mean, we were rolling pretty good out there. You know, beauty of a ship is you can get favorable winds. You can position the ship for takeoff and landing. Matters a lot with fixed wing aircraft. Again, for VTOL, it really doesn't matter much, but we did have following seas on this, so. And when this gets at altitude and distance, it's unownable. Okay, this nighttime we did some night ops as well, obviously. No issues. Again, it's all two-person lift, every component, whether it's the aircraft, any of the packaging, any of the ground support equipment, everything's two-person lift. If you noted that endurance, that's pretty good endurance. Typically, anything vertical has a less endurance than fixed wing. Obviously, the fixed wing has a problem of doing a vertical takeoff. So I know a lot of folks are coming up with different solutions for that. This is the sensor swap out we talked about. Just wanted to time it.
Correct. Just a minor point. We've got about 14 different cameras we can mount on there from about 4 different companies.
Mark, thank you. Great addition on that. Yeah, Mark, please feel free if you know, if you want to add stuff or making wrong statements there. That's a good one.
You're on a roll. Thanks.
Yeah. So you just saw the relaunch, right? 20 minutes. That's pretty spectacular, actually. Change the payload out, put it back in, take off. And just some day, night, and sorties. Did have some good wins. Good roll. I think the conditions were more challenging for the crew. Well, not for the crew, for us, than for the VBAT. Again, as you notice that gray box in the ground, right on the money. Okay, this is in the wheelhouse. Again, that's Iris, Midas is to the left. Real time. So all the tracks coming in have airspace deconfliction if required, AIS. And Dom was saving everything right there. There's the aircraft track. There was our boat in the FMV, if you saw that. So we are capturing anything the FMV puts out, we are capturing. Okay, that's that. Let me go back one more. Back to slideshow. So I am going to end it, and Rachel or Shannon, I just won't put this up here. So if you any questions on Midas or Iris, there's my name, my email, my phone number. I'll leave this up here for a little bit. Anything for Shield AI and the VBAT, there's Mark's contact info, email, and number. Please feel free to reach out to either of us. Any questions at all that we don't get to today to answer. Mark, we will be at, and I think you will too, we will be at AUVSI Exponential. There's my plug, Shannon and Rachel, for that. In April in Orlando. So we will have Iris and Midas there. I'll have demos set up. So if you'd like to come by, we can actually run through a demo for you. So for that, I guess I'll turn it back to you, Shannon, for the Q&A part.
Perfect, and great plug for Expo.
Teamwork.
We're looking forward to seeing you guys there. Yeah, the questions are rolling in, but just as a reminder to attendees, you can submit your question using the Q&A box in the bottom right-hand corner of the screen. So we are just going to jump right in, and I know we've got a few more from the Kongsberg team on the line to answer any of those real technical ones, so don't hold back, audience. The first question is, how is VBAT different from other VTOL UAS?
That's an easy one. Yeah. So that one slide I did only hit on lightly. It's a little bit smaller footprint, certainly safer. You don't have the helicopter blades spinning around like some of the competitors. You see others with the hybrid quads, which have the 4 quads around the wings. That can be a safety factor too. We're also finding that the lithium batteries that supply those are becoming a logistics challenge. Shipping lithium on aircraft around the planet can be a real difficulty. So we're finding that there are just some efficiencies with this aircraft. If you recall boarding let's say a 737 or an Airbus, like a 320 series, 321 series, when you look to your right, you see that big high bypass turbofan hanging off the wing. That's the same concept with a VBAT. We've created a ducted fan, which is highly efficient, and we're getting for about the 6% cost, if you will, for lifting the bird off the ground. That's what we have to carry with us. Whereas most other systems that are carrying their launch and recovery equipment with them, it's about a 20 to 25% trade-off. We're enjoying about 6%. So that's how I'd answer that. Thank you.
All right, perfect. Thank you. So a question came in while you were talking about Midas. Are there any UAS radars integrated into that?
Dom, do you want to take that?
Yeah, absolutely. So there are no integrated radar systems with the Midas platform. The Midas platform is actually using an offline map server that's self-hosted on the same unit as the software itself. So the information that comes in is provided to it from an external source. In this case, this would be the GCS for the UAV. So we get that information over IP multicast as HTTP packets. It's all network based. It's a lot higher like transport layer. So we don't support radar information directly. We just support information as it's provided to us in standing 4609 format or sending in Kestrel format, and we assign that to a mission and show that on the screen instead.
I add a piece to that as well. Was the question directed only a radar such that a surface search or perhaps an air traffic control radar, or are you talking about the radar on the VBAT itself? Because if it's on the VBAT itself, of course, we're going to be piping that through Midas. So we can do that, of course.
Perfect. I'm not sure exactly what the attendee was asking. Please feel free, attendee, if you want to follow up with any qualifiers there. But until we get that, I'll move on to the next question that came in, and it asks, are you familiar with or doing anything in support of the U.S. Army ALE effort?
For whom? Was that for Kongsberg? We both could answer that.
Well, why don't you each take a stab at answing?
Mark,
I'll take a quick swing, and I'll say yes in about 3 levels of yes. But due to the nature of that project, can't go any further than that.
So the airborne launched effects, it's interesting. Obviously, for those who don't know what it's about, it's other aircraft, could be manned or unmanned, launching multiple UAVs out the back. Those UAVs could be in a swarm. It could be a leader-follower type role. It could be independently controlled. And those separate UAVs could do ISR. It could serve as decoys. It can go into A2AD, anti-area denial. There's missions for the ALE. There's actually news this week about an ALE integration that's occurring. We're keeping an eye on it. We have a teammate that we're working with a little bit on ALE on the software side, but right now we haven't done anything more than that. We are following it. We think there might be a play, but we haven't done more than that. If anybody that asked that question is interested in discussing, please reach out to me. I'd love to talk to you, or Mark.
Yeah, and I'll just say the AI part of Shield AI is heavily involved in ALE, and Rex, you touched on it, but seriously, I'm not allowed to talk about that. But and I don't mean to sound secretive, not at all, but AI is a big part of that to enable, you mentioned the area denial, access to things that we just couldn't do 2 years ago, but now you can. So just know that capability exists.
All right, perfect. Thank you. You had a little bit that you talked about in terms of the cognitive overload piece. So a question came in from an audience member that said, I see the desire to reduce cognitive load in platform and sensor operations. And then they ask, what about for targeting or real-time PED?
Chris, do you want to take a shot at that?
Yeah, sure. So yeah, Midas, it uses the sentient kestrel for targeting moving targets. We also can use the payload for targeting tracks. If the payload camera, for example, can follow a track, Midas can kind of load that feed in. We do have plans, and it is on the roadmap to kind of add in AI recognition into Midas. So, the vision is that if you see, an item of interest in your live data, that you'd be able to do a search to see if that point of interest has kind of occurred in past historic files. So that is something that we're definitely investigating in. As far as a PED tool, we don't love to call it a PED tool, and that's because we really see Midas's bread and butter being at the tactical level, and not that full edge PED tool that's connected back to headquarters and big office buildings. We want it to be at that tactical level and kind of enable those front end operators that analysis capability to kind of go through and make those kind of real-time decisions based on historic data as well as real-time data.
And Chris, if I could add to that, Shannon, as well, the processing, exploitation, dissemination, the PED tool, more of a back headquarter type level, but you can envision this as a PED level 0, if you will. I mean, we gave a maritime asset situational awareness. We gave it an analytical capability if it wanted to look at any kind of a ship or any kind of the life preserver, the dive mark, whatever those could represent. So I know what Chris is talking about. In a sense, you could kind of say, yeah, we're PED level 0, if you will, at the tactical edge.
I would add a piece too, and this goes back to that theme that I have for what can we do now you couldn't do 2 years ago. A few years ago, PED or FMV analytics, a lot of that was done downstream, if you will. In other words, plug into the back of the GCS, the work was done afterwards. Most of the camera providers, the payload, the EO and the IR camera providers that we work with are embedding a very high degree of FMV and analytic software now that they didn't used to into their camera software. So quite frankly, we're not really seeing the need for an additional separate PED system. And again, that's a change in 2 years. Thank you.
Thank you. Great answers. So moving on, we had a couple questions come in surrounding weather. So I'll start with the first and then go into the second one. And you had mentioned some challenging weather for the test. So what is the roughest weather that it is capable of flying in?
Oh, I've got one. Well, we actually thought we were going to lose one down in the Caribbean. In fact, if you look at the video of the Combat Information Center, you see a lot of the operators sitting back with their arms folded, shaking their heads, going, "Oh, we're toast." We were in a double squall system about 50 to 60 miles long. That translates to about 40 millimeters, about 1.5 inches of rain per hour pouring down with hail. And we had 2 of those we had to fly through to get back to the ship, thinking we're toast, thinking, kiss that bird goodbye. There's a video, I think it's on YouTube, that shows this little old lonely VBAT coming back after about an hour, having flown through those 2 storm systems. in 35, 40 knot winds and landing on the back of the ship autonomously. It's a really cool video. It's like having your child come home after a rough night at the prom or whatever. But so we've routinely flown, I would not say in those conditions, but certainly very challenging conditions to include high temperatures, very cold weather operations to include a high degree of salt fog and frost. But certainly the heavy rain is tough on any small aircraft, but we've designed it in such a way that the rain really just doesn't affect us that much. I think it was to our surprise that it just didn't affect us as much. And that's been a blessing, believe me, considering the operations in the areas where we're operating. Thank you.
Absolutely. Thank you. So along that same weather line of questioning, this attendee asks, how was the flight planning process for these tests? Specifically, how did the weather conditions impact the flight planning and executions?
So I'll take the first stab on that.
Yeah.
You know, we looked at the weather, and again, the wind was at I believe the limit for takeoff and landing. I think it was 25. Mark, correct me if I'm wrong. We were right there. Ship and roll for every system, even manned aviation, the ship's going to have limits depending on the aircraft type. As I said, the captain put following seas, so we were doing more of a gentle roll than hitting the waves head on, which would have cost more of a kind of a compression, if you will. So we could mitigate some of the weather by the ship's heading. So that's the beauty of a maritime capability. But you know, we flew within all prescribed limits. Again, day, night. No problem. So it's up to the VBAT and you know with the 128 what those limits are. We had no problems. We would get the weather and say, okay, it looks great, let's do it.
Yeah, I'll add another small piece to that, and that is, you know, not only pitch and roll of the ship, but also heave of the back deck or the front or wherever you're taking off and landing from. We've taken off from the front of boats as well. And I use the term boats in patrol vessels because that's what we're doing a lot of flying off of. And some of those are very small, I don't know the nautical term, they're not very wide, flat bottoms. They're pitching and rolling around like corks. And honestly, it's seems to be harder on the operators than it is on the aircraft. It's not uncommon to see a pale green looking operator and the aircraft's operating just fine. So it doesn't seem to affect us that much. Thank you.
Right, perfect, thank you. So we had a question come in via the chat that asks, does it have a fixed camera for the UAV pilot and another for the payload operator?
Did I understand, are there two different cameras, one for the pilot, one for the operator? Did I understand that correctly?
I believe so, yes.
No, it's one camera. If you look at the GCS, the ground control station, it comes in a hardened Pelican case, a 1660 case. And we put it in that because the Army said it had to be parachute proof. It doesn't need to be in that. Very basic laptops. But in that, when you flip it open, I think Rex had a really good picture of it. In fact, the one with the Sheeble in it, I think that was our GCS. But anyway, that was good. But that picture there is the GCS. So the camera and the let's call them the health of the aircraft things that the operator is using, the person who's flying it, if you will, are side by side. So the one person, you don't need two people, you need one person. One person's flying, one person's operating the camera. Now, if you get super busy and there's a big op going on where you got to do a lot of talking on the radios, you may want to have someone dedicated just to the camera. But honestly, you can fly it, quote unquote, fly it and operate the camera at the same time. They're right next to each other. So long-winded way to answer, no, they're not separate cameras. They're one and the same.
All right, perfect. Thank you. The next question that we got was, what is the fuel type? And then a second question to that, what comms band are you using?
Yeah, fuel type, we've got, I'm going to call it 3, when in fact it's actually 2. Heavy fuel and then gasoline. We can use 95, 98 low lead right out of the pump. So a lot of times we're overseas, it's too hard to get the racing fuel, the C9s, the C10s. So we just go to the local gas station and get a sample, check the fuel, and then we just use local gas. We can use the higher octane, cleaner, if you will, C9, C10s. They are certainly a lot lower in carbon and are better for the engine over the long haul, but we don't necessarily need those. Thank you.
Perfect, thanks. The next question is about GPS denied environments and basically just asking how well does the system handle a GPS denied environment, and is this part of the developmental roadmap?
I would say I'm going to answer from the back to the front. It was a part of the development roadmap because we've already developed it. So in a GPS denied environment, there are several levels of operating in that environment. You would imagine increasing capability, and what comes with that is increasing levels of classification. So the higher level that we're working with the U.S. Navy, U.S. Marines, and other forces is a much higher level of protection for GPS denied. We've got some other middle exportable capabilities. And then the AI portion of our name is allowing us to operate, and is going to, in the future, allow us, very near future, allow us to operate in those environments because it doesn't need those things to navigate and fly. So three levels. I hope that was helpful.
Absolutely, that was really interesting. Thank you. Next up, how is IRIS used for BV loss deconfliction?
Chris, I'll throw that one to you.
Sure. So yeah, IRIS can pull in data from kind of a number amount of sensors, and it uses kind of all that data, and it has its own deconfliction services that it uses for both, terrain avoidance or track avoidance. So if your own ship comes within a certain threshold of any other tracks, it can alert the operator, and then the operator can take action to deconflict. So it has a number of services that will alert the operator if they're flying in kind of an unsafe area that has other tracks in the area. There's also decision aid tools, such as a range bearing measurement tool. So you can at any time measure the distance from your own ship to any other either track in the area or mountain or terrain in the area, so that you can always see full situational awareness around where you're flying.
All right, perfect. Thank you. We are running short on time, so this might be our last one. Another audience question that came in asked, is there any flight recorder system integrated in the UAS, and do you follow any certification requirements from regulators to certify the structure?
Yes and yes, and that includes U.S. as well as our EASA, EASA friends in Europe, and of course, there are a variety of them in Asia, according to each nation. But the answer is yes to both.
Well, perfect. That was a quick answer. I think I can squeeze in one more question, and it's: can Midas run multiple missions at the same time?
For you.
Yes, absolutely. So it certainly can. So what we currently have set up is it receives things over a network. So if you had multiple GCSs plugged into the same network or some way that it could access all of them, it can receive telemetry from all of the GCSs at the same time. We have some configurations in place to limit that number, but that limitation is not a limitation of the software itself. It's a limitation of the hardware running the software. But we can run multiple missions off of the same IP multicast address on different ports, or multiple IP multicast addresses on the same port, or different multicast addresses in different ports. We can intake as many as the computer can handle.
Perfect. Well, that will end our Q&A time, but I'd like to throw it over to Rex and Mark for any closing thoughts or comments if you wanted to share before we wrap up today.
Sure, Mark, do you want to go first?
Just a quick shout out to Paul and Brandon from In Situ. Hi guys. The other thing I do want to say, Rex and team, is that this has been a fun and growing partnership, not only from the business level, but from the personal level, the friendships that we've forged. You guys are onto something really important here, and we're glad to be a part of it. And thank you to AUVSI for letting us share what we're doing. Thanks.
Just real quick, I know it's 4 o'clock. So yeah, Mark, same here. Mark and I started last year together on our first trial in Oklahoma. They say what happens in Oklahoma stays in Oklahoma, so I'll leave it at that. But it's been good. You know, Dom and I have gone out to Texas a couple of times. We've done integration. You know, the Martin UAV Shield AI guys have been good to work with. We've enjoyed it. And again, Shannon, for you and Rachel, thanks for hosting us. Look forward to the exponential.
Well, thank you both. We look forward to seeing you there. So on behalf of AUVSI, we would officially like to thank Rex and Mark for this excellent presentation and discussion today. Attendees, as a reminder, you will receive a link to access the webinar recording, along with a copy of the slide deck within the next week or so. We would once again like to thank Kongsberg Geospatial for their generous support of today's webinar. And be sure to check back frequently to see future webinar offerings, including the future Kongsberg Geospatial webinars that are tentatively scheduled for May 18th, September 21st, and November 9th. So to register, you just visit our website at auvsi.org, click Events and Webinars. If you have any additional questions or comments for us today, just feel free to reach out and email us at education@auvsi.org. And lastly, today's program is copyrighted by AUVSI with all rights reserved. So thank you all for joining us, and we hope you have a great rest of your day.
Thanks, everybody. Thanks, Shannon.